This is problem 15 on the Solving for an Unknown worksheet in Mastering Physics Fundamentals. We have a car executing a turn on a banked road. Student has the following force equations. One's from the horizontal direction and the other is from the vertical direction. The unknowns are the normal force and the frictional force. Two equations and two unknowns. One way to do this is to keep the sines and the cosines throughout, only substituting in them at the very end. Another is to substitute values as soon as you see the sine and the cosine. We're going to keep them throughout. You can do whatever you want. So we're going to solve the top equation for the unknown, Fn. So the first thing we're going to do is subtract FR cosine 10 degrees from both sides. This leaves that. Now to get Fn, we just divide by sine 10 degrees. Dividing both sides by sine 10 gives us Fn. And we're going to leave the sines and the cosines in. Now we can substitute this expression for Fn into the bottom equation. Here's the bottom equation. This expression goes right there. And there it is. There's Fn right here in the square brackets. It's going to get messy because we're going to be leaving all the trig functions in. So distributing the cosine 10 degrees, one goes here, so that's cosine squared over sine. There's the FR. There's the left-hand side. Now we're going to isolate the FR term by adding this to both sides. Then these terms add to 0. We're trying to get the FR on the same side of the equation. Now we subtract 15,000 newtons from both sides. And these are just forces, numbers. And these are functions of FR. And we can combine these two, factor out the FR. Now we divide both sides by this square brackets. And we're done. We have FR. We just got to punch the buttons on the calculator and be careful. Substitute in for cosine 10 degrees and sine 10 degrees. And doing that, we get 3,300 newtons for the frictional force. And we need the normal force now. We have an expression for the normal force in terms of the frictional force, and we plug it in, and we get 15,800 newtons. That's problem 15.